Hey everyone, welcome back to another video by Camroom 5. In the previous video, we had started talking about the isomers and we talked about their definition. And then we also talked about the phenomena of nomenclature within organic compounds. We said that we need to identify the longest chain, especially if it's a branched one. And apart from the branch, whatever longest chain we are left with, we allocate numbers to each carbon atoms, especially from the corner wherever the branch is closer. And then we talked about how we call methyl propane or methyl butane based on the branch and whatever the longest chain is. Then we looked at how butane and 2-methyl propane are isomers of each other, and similarly pentane and methyl butane are isomers of each other. Now I want you to look at these two structures, which are both 4-carbon compounds, and if you look closely you would be able to identify that both have a carbon-carbon double bond. So they are both unsaturated and they both belong to the alkene series. But we need to see one thing, that when I allocate numbers to both carbon chains, for example carbon 1, 2, 3, 4 and carbon 1, 2, 3, 4, I can clearly see that the double bond, the carbon-carbon double bond, is in the corner for one compound, but it's in the middle for the other compound. The carbon-carbon double bond starts at carbon 1 for the compound on the left, but it starts from carbon 2 for the compound on the right, which means that the double bond is between carbon 1 and carbon 2 for the compound on the left, but the double bond is between the carbon 2 and carbon 3 for the compound on the right. So their names are going to be different. We're going to call them butene for sure. They're both but because they have 4 carbons at the end of the day. But when we call them ene, we place a number before the E and E. Why do we place a number? The number indicates the position of the carbon-carbon double bond. The position indicates where the double bond is starting. So in first case, we're going to call it but 1-ene, but for the second case, we're going to call it but 2-ene. That 1 indicates the carbon from which the double bond starts. The carbon from which the double bond started. Similarly, in but 2-ene, the 2 indicates from which carbon the double bond is starting. So it is going to be called but 1-ene or but 2-ene depending on the position where the carbon double bond is starting, and that is how we get two different isomers of the same butene. In another structure, I want you to look at these three structures. I want to call them P, I want to call them Q and R. When I look at these three structures, they are all very similar because they have the similar molecular formula. All of them have 3 carbon atoms like these, so they are prop something. So they have C3. When you look at the number of hydrogens they have, they're also same. Each one has 7 atoms. You can count it obviously. But each one also has a chlorine atom in them. So they also have a chlorine atom on them. But it is the position of the chlorine atom which makes them different from each other. For example, in the case of first compound, I have chlorine in the middle. In the second compound, I have chlorine on the left, and in the third compound, I have chlorine on the right. Now, how are they different? When you number these carbon compounds like 1, 2, and 3, for the middle compound for Q, you would want to name it from the left hand side because the chlorine is towards the left hand side. And remember, it was our rule. It was our rule. If you look at the rule number 2, it says number the carbon atoms from the corner closer to the branch. So not only the branches, it is also for functional group atoms like chlorine atom. So instead of numbering it from random directions, I'm going to number it from the left side. For structure R, for the structure on the right side, the structure R, I would rather number it from the right hand side because the chlorine is towards the right hand side. It is not like in English we always do it from the left. It is very fixed. You look at the functional group, Whichever corner is closer to the functional group, you number it from there. If you look at P, the chlorine is in the middle, so there's a chlorine on carbon 2. But if you look at structure Q and R, both have chlorine on carbon 1. So they are identical to each other. They are not isomers. They are identical. They are literally the same. Both have chlorine atom on carbon number 1 of the chain. So you can't call them isomers. You can't say okay, one has it on the left and one has it on the right. They both have chlorine on the carbon number 1. So this is an important thing to keep in mind. Now let's look at these 4 structures. I'm going to call them W, X, Y, Z. If you look at their molecular formula, all of them have 3 carbon atoms, so nothing new about it. 3 carbon atoms, so they're all prop something. But what is different over here is the position of chlorine. They all have C3H6Cl2 and same as all the 4. But now, apart from the same molecular formula, I want you to look at the position of chlorine. For the first compound, you will number it from the right side because the chlorine are towards the right and there is no chlorine on left. For X, you'll again number it from the right side because the chlorine are on the right side but there's none on the left. For Y, you can name it from both sides, you can name it from either side because there's one chlorine on the extreme left, one chlorine on the extreme right. So I'm going to call it 1, 2 and 3 from the left hand side. For the structure on the Z, for the structure Z, I would want to call it numbering from the left side because there is chlorine on the left carbons, but there's no chlorine on the one on the right. Now notice one thing. For W, there's one chlorine on carbon 2, one chlorine on carbon 1. For X, again there's one chlorine on carbon 1 and one on carbon 2. For Z, again there's one chlorine on carbon 1, one chlorine on carbon 2. And that is why, guys, W, X, and Z are identical. They are literally the same structure because they all have chlorine on the same carbon. Only Y is different because Y has a chlorine on carbon 1 and carbon 3. So Y is different. Y is isomer of WXZ, and WXZ are not isomers of each other, they are same. WXZ aren't isomers, they are the same. They have the same formula and same structure. Y has a different structure. So keep those things in mind while you're numbering those compounds. So in today's video, so far we have talked about the idea of numbering. We have noticed that we number from the carbon which is closer to the double bond or which is closer to the chlorine. It can be numbering from the left side, it can be a numbering from the right hand side. It doesn't matter. What matters is that which carbon has the chlorine atom or the double bond or a branch, because you have to start the numbering from that side. Now let's do this question. It says the structure of 4 hydrocarbons W, X, Y, Z are shown. Which row is correct? Okay. Before we move forward, I want you to try naming them. First structure is a branched one. It has a 3 carbon branch. Sorry, it has a 3 carbon and a branch. Carbon 1, carbon 2, carbon 3. It should be called 2-methyl propane. The 2 indicates the position, the methyl indicates the branch, and the propane indicates the long chain. Let's name structure X. X is not branched. X is going to be simply called butane. Y is branched, not only branched, it has a double bond also. So it has a double bond also, and it also has a branch. So it is going to be called carbon 1, 2, 3. You can ask me, why am I numbering it from the right side? That is simply because I have a double bond starting on the right side. So I will call it 2-methyl propene. Why am I calling it 2? Because 2 indicates the position of the branch. Methyl indicates the branch itself. Prop means 3 carbon chain, and the ene means double bond presence. You can see how each segment of the name has something to tell you, how each part of the name has some idea to give it about the structure. Let's look at Z. Z will be numbered from left side because there's double bond starting over there, and it will be called prop 1-ene. The 1 indicates the position from where double bond is starting. The prop indicates 3 carbon chain, and ene indicates double bond. Now moving on. Which row is correct? Isomers of each other. So W and X are definitely isomers of each other. Decolorized bromine. Decolorized bromine is a quality for alkenes. So it will be true for Y and Z. Branch structures. Which ones have branches over here? W has a branch and Y has a branch. So W and Y. So A for apple is the right answer. I hope these ideas are clear to you guys. And I would recommend you complete the organic chemistry playlist, and then we can move on. Stay tuned guys. Thanks.